Hello everybody! In this video I will help you with your June exam preparation. I will discuss question 4 of the 2021 paper. This question is still on analytical geometry, which is 27% of your paper. Here you find the question. Again, I suggest that you pause the video and quickly do the question and then go back to the explanation. Here you find the rest of the question. In the diagram, the circle centered at n -1, 3 passes through A -1, -1 and C. B -4, 2, C, D and E are joined to form a parallelogram such that BE is parallel to the x-axis. CD is a tangent to the circle at C and CD is 6 units. 4.1. Write down the length of the radius of the circle. So the radius of this circle you will find there, and we know that the y-coordinate at n is 3 units. So that means this distance from there up to the origin will be 3 units. And then on A, the y-coordinate is -1. So that as a distance will be 1 unit. Therefore, if you add the 2, 3 plus 1, you will find that the distance there, the length of the radius, is 4 units, and that is worth 1 mark. 4.2, calculate the coordinates of C. What's happening at C, NC is a radius and CD is a tangent. Therefore, there's a theorem that says that the tangent is perpendicular to the radius. So we know that the x-coordinate of C will be exactly -1 n's coordinate. And then we know that Cn is a radius. Therefore, we just calculated that the radius's length is 4 units. And then from N up to the origin there, we already worked out that it's 3 units. Therefore, the coordinate of C, the y-coordinate, will be 4 plus 3 will be 7. So therefore, the coordinates of C are -1 and 7, worth 2 marks. 4.2, the coordinates of D. So what we know is that the coordinates of C is the point -1 and 7. Therefore, at D, the y-coordinate will also be 7. That's not a problem. And then also at C, the x-coordinate is -1, but therefore this distance is 1 unit. And then we know that the whole distance CD is 6 units minus this part over there. Therefore, that remaining distance there is 5, and the coordinate will be the point 5, 7, worth 2 marks. Then 4.2.3, the area of triangle BCD. Now what's happening there is this triangle BCD, this is in fact a triangle that lives inside your parallelogram. It's half of the parallelogram. So we need to find the area of a parallelogram, and in order to do that, we need to know that the base of the parallelogram will be 6 units. Since this CD is 6 units and it's a parallelogram, then this will be BE is the base of the parallelogram. But then we also need to know what the perpendicular height is, because the formula for the area of a parallelogram is base times perpendicular height. Now, how are we going to calculate that? Do you agree? We just worked out that the y-coordinate there at D is 7. So that means this whole distance there will be 7 units. But we are only interested in this little bit up to there. Now what is happening? At B, the y coordinate is 2. So that means this little distance over there will be 2 units. And we know that the whole distance is 7. So that distance over there will be the 7 minus the 2, which is 5. And we call that the perpendicular height, or in this case, the altitude. So what I did for you there, I explained the perpendicular height. The altitude of the parallelogram is 5 units. We know that the distance CD is 6 units, which is in fact also BE's distance, the base. And then the area of a parallelogram is the base times the perpendicular height, the 6 times the 5, which is 30. But then that 30 is in fact the area of the whole parallelogram. And the one we are looking for is just this triangle over there, CBE, which is half of the parallelogram. So it's half of 30. Therefore, the area will be 15 units. And then where's the marks for working out or reasoning out what the altitude, the perpendicular height was, the base, and then half of that area of the parallelogram. 4.3. The circle centered at N is reflected about the line y is equal to x. M is the center of the new circle which is formed. The two circles intersect at A and F. Calculate the length of NM. Now before I show you what's going on here, very important, there's a line or a circle that's reflected about the line y is equal to x. Where do you find that line? This is this line that goes through the origin over there, the line y is equal to x. And this is the line, a very important line, because this is where inverse is taking place. So what happened was, about that line was this reflection of a circle, and there's a new point, the point M, which is the midpoint of the reflected circle. Now I have a little drawing for you here which clearly shows this. The red circle was the original circle, the blue circle is the reflected circle, and then the green line is the line y is equal to x. And then what we are looking for is we are looking for this length of distance nm. So what I did for you was, since m is the new reflected point of n, reflection about the line y is equal to x implies that the coordinates will swap. So m's coordinate is the point 3 and -1 because of the reflection. And then it's this distance, and when we are working out a distance, we're using the distance formula. And where will we get the points? We will get the points from m, 3, -1, and from n, -1, 3, consisting of an x and a y and an x and a y. And we substitute them into the distance formula, and we work out that mn is 5,66. So where's the 3 marks? The 3 marks are here on m's coordinates, for knowing that it's the reflection about the line y is equal to x and that the coordinates swapped, and then substitution into the distance formula and final answer. 3 marks. On number 4.3.2, they want the midpoint of AF. In other words, they want the coordinates of that midpoint of AF. So what is happening is, do you agree there is a line NM And there's the line y is equal to x. And if I can calculate that point over there where the two lines intersect, that means I will be able to work out what that point is. In other words, I will be using simultaneous equations with the line y is equal to x and the line nm. But I don't know the equation of the line yet, so I can work it out. First of all, I need a gradient. I can work out the gradient of mn using those two coordinates into the gradient formula, and I find that the gradient is -1. And then into y is mx plus c, because I'm working out the equation of the line mn. You can either substitute the point n. I substituted the point 3. In x's place, I'm going to substitute 3. In y's place, I'm going to substitute -1. And m we just calculated was -1. Substitute the points, work out c, and we get the equation. Y is -x plus 2. So this is mn's equation. And then if you do simultaneous equations, then you get the point where the two graphs intersect. What is happening? We've got this other line, y is equal to x. So what I'm going to do is I'm going to, in y's place over there, I'm going to put the x. And then I'm going to solve x. You solve x, you get x is equal to 1. And then y is 1, because y is x and x is y. If one is 1, the other one should also be 1. And therefore, the midpoint, the place there, the midpoint of AF, the place where the two graphs intersect, is the point 1, 1. And then where's the marks? The marks are there for finding the equation of MN, for equating the two, because that means you understood where two graphs intersect, you will find that midpoint, x's coordinate, y's coordinate. On the right-hand side, you will find the two playlists on grade 11 and 12 analytical geometry. On the left-hand side, you will find the next question of the 2021 paper. That one is on trigonometry.